Everyone, Mr. Hissner here, and today I want to look at the properties of angles. Now, if you remember, we've looked at properties of equality. We did algebra proofs. We looked at properties of congruence, right? We looked at definitions of midpoints, and now we are going to all those properties of segments. Now we're moving on to properties of angles, definitions, postulates. What else? Theorems. So what I want you to do is I'm going to have this available to you, maybe even try to print it, but I will have these available to you. So what I want to do is just go over them, right? I just want to look at what's the definition of congruence look like with an angle. Well, just like definition of congruence looks like with a segment, where the two segments had the same measure, then they were congruent. Two angles have the same measure, then they were congruent. It goes both ways. If the angles are congruent, they have the same measure. If they have the same measure, then they are congruent. Bisector, this is just like a midpoint. It divides an angle into two equal parts. Definition of complementary and supplementary. Remember, these are 90 and 180 respectively. So if it's 90, then it's complementary. If it's 180, then it's supplementary. If it's supplementary, then it is 180. These are biconditional, so again, these are going both ways. The definition of perpendicular, these form right angles, and they make like a T. Definition of right angle, we know that is 90. Angle addition postulate, just like segment addition postulate, where we have two angles, or at least two angles, and we can add their measures, the small ones, right? Angle in here, angle out there, in the whole thing. Left pocket, right pocket, whole thing, whole total. Left pocket, right pocket, total. So that's the idea. This is our angle addition postulate, just like segment addition postulate, basically legitimately the same thing. So, okay, vertical angles. Remember vertical angles? They looked like this, and angles 1 and 2, and they were congruent. Angles on either side of two intersecting lines are congruent, and thus they are vertical angles. Complementary. Now, all right, I'm just going to slow up here just a second because the complementary theorem and supplementary theorem are different than the congruent complements. Okay, so just remember, complement theorem says that two angles form a right angle, thus it is complementary, right? If two angles add up to 90, then they must be complementary. Complementary angles do not have to be right angles, though, because they can be separate. So notice this only goes one way. If two angles form a right angle, then they are complementary. If two angles form a linear pair, then they are supplementary. Linear pair implies supplementary. This is the supplement theorem. Okay, this one we use more than this one. Supplement theorem comes up quite often. Now, I want to look at congruent complement theorem and congruent supplement theorem. They're basically the same, just with different values. So I'm going to do this one over here. How about I do congruent complement? So I have the measure of angle 1 plus the measure of angle 2 is equal to 90. We have the measure of angle 2 plus, the measure of angle 1 plus the measure of angle 3, so some other angle is equal to 90. And what this says, we say if this is true, then what we conclude is that the measure of angle 2 must be the same as the measure of angle 3, or another way to think of it is that these two angles must be congruent. The reason that is because if you look, right, take the measure of angle 1. Say that this is any measure between 0 and 89.99999. So let's say that this is 75, for example, and this is 75. Well, let's just kind of think about this as 75 plus unknown is equal to 90. And let's say 75 plus y is equal to 90. We can solve both of these problems, right? Subtract 75 from both sides. We'll find that x is equal to 15. Subtract 75 from both sides, we find y is equal to 15. And actually, this is a nice proof. We're not going to prove this because that's not part of the game. This is something that you just have to realize or recognize. And if you don't recognize it, you have to just take my word for it because it is true. And one clear example shows this. And this is that example. Now, notice how, so this was the complement theorem because it was for 90. And this would not change if I make this 180. right? So that's the idea here, is that this is what we call the congruent complement theorem. It's congruent complement theorem because they're complement and supplement, but also they have a congruency. The supplement and complement theorem says that they just add up to 90 or 180, that if it's a right angle, then it's complementary. If it's a linear pair, then it's supplementary. That's what that says. So there's the difference there. Thanks for watching, guys, and we will have some practice in the next video.